And our goal here is to simulate a tank level. And when we get a greater than 5, our green light comes on representing our pump. And now we can go below 5 and it continues on until we get back down to 2.5. We still have our sim ALP2 connected to our compact logics and our scaling from our function block exercise.
At 4 milliamps, we have 0. At 20 milliamps, we are at 23.1.
At 5 feet, we should start our pump, and at 2.5, we should stop our pump. Let's open up our main routine, bring down a new rung, which is the left icon, and let's get to our compare tab and find the GRT, which is a greater instruction. And in that source A, double click on it and find your level. And then in source B, let's simply type 5 for 5 feet. Now let's get our favorites tab and bring down the output energize, which is the third from the right instruction. And we have our green light representing our pumps. That's going to be local :1:0, and hit your arrow to the left of it, and then data, and then hit your arrow to the right of it, and we want 0. And while we're at it, let's go ahead and put a description in it. So let's right-click local, and midway down, let's edit main operand description, and let's call it the green light. So where do you think the 2.5 needs to come into play on this?
In the middle.
Let's go to our compare, and are we looking for a greater than or a less than?
Greater than.
Okay, so bring down a greater than, and level, and 2.5. And this is exactly what the students that come to our training center think at first. When will this actually be true? What does it take for this one to be true?
For it to be over 5.
So at that point, does this greater than ever do anything? Because if we're greater than 5, aren't we also going to be greater than 2.5?
Yes.
So what's another way we can do this?
We can add a branch.
So let's bring down that second from the left icon and put it before that first greater than. Now drag your blue bar over top of the greater than, and drag that second greater than into that lower branch. When is this one going to be true?
When it's greater than 5.
Well, what about this lower branch though? See here, if it's greater than 2.5, isn't this lower branch going to be true?
Yes.
This is exactly where students end up at. And I always ask this question afterwards. So Amber, if our tank is empty, should our pump be running?
No.
At 2.4 feet, should our pump be running?
No.
At 2.6 feet, should our pump be running?
No.
That's right, because we haven't got to our start level yet. So at 4.9 feet, should our pump be running?
No.
We hit 5.1, should our pump be running?
Yes.
Okay, now we go back down to 4.9, should our pump be running?
Yes.
What's the difference between the first time we hit 4.9 and the second time we were at 4.9?
The second time the pump was already running.
And that is the key thing to understand about how to do this type of logic. So we're going to create what's called a holding circuit or a memory circuit or a CLN circuit. And to do that, we're going to go back to our favorites tab and bring down the go look for a 1, which is the 4th instruction there, and put it in that lower branch. In our case, we're using the green light to represent our pump. Now here's a really cool shortcut is you can just click on that local and now hold it and drag it over the green spot by that question mark. Now let's go ahead and finalize this edit. Now we're going to take our ALP2, which we previously configured for a sweep cycle. We're going to go to current source, and then I'm going to click the OK button, and I'm going to put it into the sweep cycle. And that's simulating a level from 0 feet to 10 feet and back down. And let's check out what we have, Amber. So right now we're climbing up to 2.5, and as soon as we hit 5, we get our green. And now it's going to drop back down. And when we get below 2.5, it's going to turn back off. Now I just paused it. So we're at roughly 1 foot. So is our top greater than true?
No.
Is our lower greater than true?
No.
So we don't have a continuous path from left to right. So that output energize on the right side is going to go right of 0. And now I'm going to bring it up. And I'm going to pause it when it's above 2.5. So is the top greater than true?
No.
Is the lower greater than true?
Yes.
But we have that go look for a 1 on output 0. And since our pump is not turned on yet, That is still false, and that's going to keep it false. Now I'm going to bring it up above 5 feet. Is our top greater than true?
Yes.
When that is true, we'll have a continuous path from left to right, and it's going to write a 1 to output 0. And that's that go look for a 1 there in the lower branch. So that's how we're going to remember that it's happened. And now, as it pumps back down, we're at 4 feet. Is the top greater than true?
No.
Is the lower greater than true?
Yes.
That's right, because 4 is greater than 2.5. And now we remember the pump was running, so it's going to continue. And we'll resume on, and I'm just going to pause it down here. So now we're at 1.4. Is the top greater than true?
No.
Is the lower greater than true?
No.
Since we don't have a continuous path from left to right, that output energizer is going to go right to 0.